I'm only Ed Crawley. Johan will come later. Well, good morning, and welcome to the CDIO International Conference. And I want to, for the first time, but not the last, thank Martin and the excellent organizing effort that's been done here at DTU. I think it's quite obvious, the energy and the work that's been done. By tradition now, I guess, we begin these meetings with a short overview of some contemporary topic in CDIO. And since this is our approximately 10th anniversary, depending on how you count, we decided this year that we'd do a retrospective and look back and look forward. So the origin of this is the idea that many educational developments are managed as projects. A project is, by definition, something that has a finite beginning time and ending time. But the renewal of education, of engineering education at the university, can be viewed as an ongoing process of continuous improvement in quality. And therefore, we wanted to try and recast CDIO as a means of continuous process improvement to take hold and to have long-standing impact. Such things need to be able to continue to be sustained and to be institutionalized. And there are actually few such cases in the literature where a broad educational movement has had this sort of continuity. So in this presentation, we want to not only look at what CDIO has accomplished and might accomplish, but maybe to step back a little bit and look for the indicators that it might be an ongoing, continuous process. This was, by the way, not an obvious thing at the beginning, as I'll explain in a few minutes. So the aims are to provide an account of this process and discuss the results, and to identify what might be the critical success factors. So this is the talk as Johan and I will give it, and I'll basically talk about the first bullet, which is quite about half of the talk, about the journey up to now, and then Johan will come and give the retrospective and future forward-looking. So the origin of CDIO, as many of you have heard me say, is really in a movement that began in the 1950s and 1960s to reform engineering education. It was what we might call the first wave of reform. To move engineering education from a practice-based education to a science-based education, the so-called engineering science movement. And if one looks at the and examines the documents written in those days, it's quite obvious that the founders of that movement, who were principally in the United States, intended very deeply to improve engineering education by introducing some basis of science, but not to replace the education of practice. But in fact, that's what happened, that the education in practice was almost totally replaced by the education in science, engineering science. And employers started to notice this. Even as early as the 1980s, employers started to notice this. And two that are sort of important to the evolution of CDIO are the Boeing Corporation in the United States, which by the 1990s was quite actively organizing meetings to try and get university engineering programs to understand the change that had happened. And the Wallenberg Foundation family enterprise in Sweden. And these organizations, these large industrial organizations who hire many engineers, so they could see the change that had occurred as not just occasional but systematic, really began to understand the need to work with universities to make them realize what was going on and how to improve it. One of the ways they chose, I would say not very successfully, was to try and influence the accreditation processes in nations where those existed, such as in the United States with ABET. They actually, in the mid-1990s, made an organized effort to try and change the accreditation process so that it would move the universities along. They also tried to produce what I'll call lists of perceived deficiencies, and I would call this modest impact at best. That the universities were set on this engineering science path, and the input from the industry was really not being listened to at universities by and large. In 1997, I led a strategic planning exercise at MIT which identified CDIO, and we used those letters, those words, that conceiving, designing, implementing, and operating, as an opportunity to bring this best practice into education, this synthesis of engineering science and engineering practice. But the critical meeting of this entire venture was one afternoon when several of us at MIT met Peter Wallenberg, who at that time was still the head of Investor AB, the Wallenberg holding company in Sweden, and described CDIO to him as it had evolved up to that point, only about a year or two. And he recognized that this was an opportunity to bring together some universities in Sweden with MIT to develop this model more fully and to have it have some nationwide impact in Sweden, where, of course, most of Wallenberg's enterprises are located. So he and a fellow named Billy Fredrickson, who at that time was a senior technology person, later the chief technology officer of Saab, introduced me to the rectors of a number of Swedish universities, and we came together at an initial meeting in January of 2000 in Stockholm, and found really remarkable alignment, remarkable commonality of our interests. It was like meeting your brothers and sisters who had been separated from birth. You know, it was remarkable in one meeting how quickly we congealed and formed a team of like-minded people. So, of course, that's good, but money helps too. And that was followed up by a proposal to the Wallenberg Foundation, who then funded the effort for 5 years. And actually, an interesting retrospective today is it was very much unclear for many years whether the CDIO initiative would survive the 5 years of the Wallenberg Foundation funding. You know, it's easy to get people to work on something when there's funds available. The question is what happens next. So, for example, these are the objectives that we wrote in the original proposal: to educate students to master a deep working knowledge of technical fundamentals, to educate engineers to lead in the creation and operation of new products and systems, and to educate future researchers to understand the importance and strategic value of their work. And unless you have the book in front of you, I would defy anyone to notice the changes that we've made in those words in 10 years. There's actually a few very subtle changes in wording that we've introduced. But in fact, the objectives that we wrote down in that meeting at KTH in January of 2000 are exactly the same objectives with a few changes in wording that we use today. Remarkably stable for an effort that was at that time only 1 day old and is now 10 years old. The first major project that we undertook in the CDIO collaborative, which at that point had 4 schools, KTH in Stockholm, Linköping University in Linköping, Sweden, Chalmers in Gothenburg, Sweden, and MIT, was to formalize a taxonomy for learning outcomes for engineering, which has become known as the CDIO syllabus. Now, we actually had been working on it for about 2 years at MIT when the universities first met, and had gone through many documents, focus groups, drafting, review processes, and so forth. So it was a sharing of this document that was in process with the Swedish schools. And again, there was remarkable agreement that this was the basis of planning. I think that the discussions with the Swedish schools primarily reduced what might be called some American jargon that was in the document. It introduced the idea that engineers should be able to communicate in a foreign language, which of course is not commonly held in the United States. It moved the document a little bit away from aerospace terminology to a more neutral technology. But by and large, the document was accepted largely as it had been developed. So the syllabus, which is designed as a taxonomy for learning outcomes, actually has become a way to communicate with professors and stakeholders. I find it very often the case when a national accreditation system or a national evaluation system or a president of a university says we should teach our students more about communication or more about ethics. that these are topics that many engineering professors don't actually know the content of. You know, we have some vague understanding. My colleague Rob Nieweiner is in the room someplace, who introduced this marvelous set of resource materials about critical thinking in the last few years. And if you haven't read his booklet or gone to one of his seminars, I highly encourage you to do it. So it turns out that at almost every university in America, they say, we teach our students critical thinking. So I've just started asking, oh, what's critical thinking? And it's amazing how quickly people start stumbling trying to explain, especially engineers, how to explain what critical thinking really means, but everyone knows it's important. So just helping people understand the content that is associated with the words we use is actually a very valuable contribution. We can use it for benchmarking, for how and where do you teach ethics, and how and where do we teach ethics. Obviously, for setting learning outcomes, and increasingly national accreditation systems are, and international accreditation systems are focusing on outcome-based education. For actually designing the curriculum and measuring student learning, although one of the things I think we've found in the last decade is just how difficult measuring student learning is. So if, for example, we look at the impact that we're having in the CDO collaboration, I would observe that today there are about 60 programs in CDIO. By the end of the week, there'll be about 70 programs in CDIO, 70 universities. On average, those universities have between 1 and 2 programs, some multiple programs like here at DTU. So there are at least 100, maybe as many as 200 programs around the world that have used the CDIO syllabus in some form or another to influence their planning and education. And the document has been translated into the languages indicated here. And in fact, last month I was in Vietnam, where in Ho Chi Minh City, where there's a pilot program of 2 departmental programs that are the pathfinder for adoption throughout the Vietnam National University system. Another important discussion was the context. This was to adopt CDIO, Conceiving, Designing, Implementing, and Operating, a product lifecycle, as the context but not the content of the education. And it took me some time to realize that this word context does not translate well into many languages. So let me explain in a little more detail. A learning context is what you're surrounded by as you learn. It's the combination of the environment and the values that you are surrounded by, and the applications. So it's a set of cultural surroundings and environment that contribute to understanding. A context allows you to understand. If you saw a sign in Danish in the middle of Peking, it would be confusing. If you saw a sign in Danish in the middle of Copenhagen, it would be more easily understood. Just the fact that you're in a Danish city actually helps you understand a sign in Danish. So the settings of education, the skills we teach, and the attitudes we convey should all form an integrated whole. It should be that the students understand from the first day that they arrive at university that their role is to build things and to design things and to work in teams in order to make products that are useful for the betterment of humanity and the environment. Now, it's so obvious, why do we have to say it? And of course we have to say it because most of us are not engineers. Most of us are engineering researchers and engineering scientists, and we have subtly conveyed to the students the values of engineering science and engineering research, not the values of engineering practice. So this very foundational statement that conceiving, designing, implementing, and operating is the context of the engineering education is sort of foundational. It's the bedrock on which the program is built. Now, I have come to find that it's both an advantage and a disadvantage, and in fact, I had a group of colleagues from Sweden in my office recently, and they said, you know, there's a problem with this, Ed. I said, what's the problem? They said, well, we noticed that CDIO around the world is more widely adopted in mechanical and aerospace departments than in other departments. And there is certainly the truth to that. There's some bias in the representation. Although it is also true that it's now been implemented in chemical engineering, material science, civil engineering, biological engineering, all of the different fields of IT. But there still is a bias. And they said, in mechanical engineering and aerospace engineering, there still is a professional discipline associated with design. Whereas in some other engineering disciplines, we are so distant from design that it's hard to actually recreate the expertise. I think that was a very interesting observation, that there are chemical engineering departments, arguably, I'll just choose that as an example, where there's nobody left on the faculty who actually thinks of design as a principal part of their scholarly work. So that's both a strength and a weakness now there are ways around that, but another of the early outcomes, this is now moving on a few years, are the standards or the principles of effective practice. It's interesting how these came about. We didn't actually create them for any of the reasons that we now use them for. We created them because we had an industrial advisory board, and we said, would you pay graduates of a CDIO program more money because they graduated from a CDIO program? And this was actually asking industry to put, as we say in American English, put its money where its mouth is, right? If they're going around to a university saying, you should do this because it educates students and we need students who are better educated to come to work for us, they should be willing to pay those students more. And they had a very interesting answer. The answer was, how would we know that it's a CDIO program? Because it could be that programs which didn't have the letters C, D, I, and O anywhere in their name were in fact using all of the effective practices, and it could be programs that had CDIO in their name were just using it as advertising. So we decided to respond to this, and we said, what are the essential features of a CDIO program? And that's how the standards became about. So we developed these based on the characteristic of our early vision of CDIO and best practice in the pedagogical and the scholarship of learning. We developed it based on discussion and consensus, and we wrote each one with both a standard, an explanation, a rationale, and a set of evidence that could be used to demonstrate that a program was meeting this standard. But since that time, I think it's fair to say that the 12 CDIO standards have become much more an organizing principle for our activities, for our meetings, for the book, and I think most importantly, a self-assessment process. And I really believe that this is one of the features that we've created that will have some long-term sustainable effect. That when a program sits down and evaluates itself using the CDIO standards, not when the national accreditation body is coming, because that's just sort of work. But when it actually sincerely sits down to evaluate itself and asks, how well are we doing on this principle of effective practice, and what can we do to improve? That's the most sustainable aspect of the program. We also quickly organized ourselves into these 4 themes of curriculum, teaching, and learning, design implement projects in workspaces, and assessment and evaluation. And if you read the book, or if you look at the standards closely, you see the remnant of this organization of these 4 themes. And when all of the CDIO collaborative could fit around this table rather than in this room, we would have working groups in these 4 areas, and each of them would do projects like writing a curriculum design guide or working on active feedback for real-time applications, peer instruction in a classroom. And from these themes, as I said, grew the standards and the I-kits in the book. So if we look back at about 2005, about halfway through our 10-year journey, this was what was accomplished by the end of what we'll call the Wallenberg project phase. We had developed the syllabus, we had developed the standards, we had already identified a governing structure of the council and set up the beginning of the regional structure. We had created a website, and this series of conferences had begun. This is the 8th conference, right? 9th? 7th. This is the 7th. I knew that. This is the 7th, which means, if my arithmetic is correct, the one at Queens must have been in 2004. 5? 5, says the guy from Queens. Do I hear 6? I've always wanted to do that. And we had 12 collaborators. Now we will welcome about 12 this week. So you can see the pace at which things are spreading. And I think we had in place the fundamental elements for international development. So here is where I will finish with the retrospective look. This is the timeline, and it really begins in about 1997, when at the department I led at MIT identified CDIO and the undergraduate education enhancements. In 1999, the meeting with Peter Wallenberg and the invitation to go to Sweden. Early 2000, the drafting, the first project meeting in late 2000 in Linköping. The syllabus adopted in 2001. Very interesting, we had no intention or no explicit desire to welcome other schools into this group. I mean, it seemed to me it was a project with 4 universities and it would last 5 years. And all of a sudden, people started hearing about it, and the first group to come and visit us of their interest was from Queen's University, Belfast. And that gave us the idea that, well, maybe it would be an interesting idea to get a few other interested programs involved so we could test whether the material that we were developing could be adopted by others. And that was really the beginning of the outreach. And those 4 schools included Queen's University, Belfast, Queen's University, and Kingston, Ontario, Canada, the United States Naval Academy in Annapolis, Maryland, and the Danish Technical University, one of the first 4 schools other than the original group. We adopted the standards by about 2004, where we built the council and the idea of regions, had the first conference in 2005, formed a larger set of regions, and then we came to the end of the Wallenberg money and said, will it last? Well, we published the book in 2007, which I think has been instrumental in letting people around the world know of the ideas that have been developed and codified. By 2009, we had the first conference outside of North America and Europe, that is to say in Singapore. And in 2010, we went through a revision of some of the major foundational documents, and here we are with 62 schools at DTU again. So at this point, I'll turn it over to my colleague and partner, Johan, who will talk about the future.
Or to start with the present. And you could ask yourself the question, what is CDIO of today? And I'll give a few perspectives on that, how you can see this kind of collaboration and framework. And there's at least three ways you could look at that, of this contribution. You could look at it as a method, and what does that mean? You could look at it as a set of people, and what does that mean, and what is the value of that? Or you can look at CDIO as a collaboration platform. So we start with CDIO as a method, and Ed was onto it a bit when he said that you started by formulating a vision for engineering education, emphasizing certain key elements. Design, implement projects, and do learning of knowledge and skills. And those were sort of targeting what we felt was missing in engineering education at the time, and that many others also pointed out, that engineering education has drifted towards disciplinary knowledge and analysis, and then going away from design, going away from multidisciplinary things, going away from engineering practice. So, but at the same time, we did not want to say that, well, then we're going to replace analysis with design, but try to find an educational model that emphasizes both the ability to know things about solid mechanics or thermodynamics or mathematics, and the ability to implement those in practice, use them for design purpose. And to do that in an integrated fashion, where you would learn design, so forth, by applying it. And you would learn to communicate about engineering by doing it in engineering projects rather than in separate courses. So those are the few ways of looking at engineering education, which is part of CDIO. But then if we become a bit more specific and go into some of the aspects that Edward was talking about too, you can also see CDIO as a language, right? A codified framework that enables us to discuss these things with a bit more precision than going from that first vision. So, well, we want to emphasize skills, but what skills are we discussing, right? So the CDIO syllabus is a taxonomy that enables us to do that, and which is something that has been demonstrated to have an international value. We have done many comparisons over the years with the national frameworks in Sweden, in Canada, in the United States, and seeing that sort of the CDIO syllabus is something that binds these together. We can always go from the CDIO syllabus back to these national frameworks. So we have something that we can talk about in an international context rather than comparing the Swedish to the Canadian to the American national frameworks. And that is something that is facilitating these discussions. CDIO provides a process for engineering education development, including the continuous improvement aspect. So if you're going to change engineering education, this is, regardless of, we say, a major undertaking, perhaps done by someone who is not a designer in himself. Well, if you can say that, well, you're not a mechanical designer if you're an engineering professor, but you're not necessarily an educational developer either. And that is also a design process where you need to understand the needs. We want to look at the alternative solutions. You will converge on something. You will create an architecture you would carry out. So those are other things that have been described in the CDIO framework as a process of going from need to educational plan. And then with a framework for evolving over time, that rather than just looking at thresholds, that an accreditation system, something that enables you to look at what you're doing, find out areas where you can improve and move on. So, and finally, you can say that CDIO as a method is also a set of tools for solving tasks in this design project. A number of templates for writing program goals and so forth. So that is one way of looking at CDIO. And so, but we can also look at CDIO as a number of people. As we see here in the room, there is a lot of people who are engaged in this idea and working hard with it. And so this forms a community of practice. And perhaps the unique thing about this, that this community of practice is dominated by program directors and by teachers, not by deans or not by teachers or not by educational researchers, but by program directors who have the responsibility and, in a sense, the power to drive the development of their programs. And this is something that is unique for CDIO, I think, perhaps. We've seen that CDIO has become recognized as an actor in education policy making across the world. In Sweden and in China, for example, CDIO has had an influence on the national frameworks. As a recognized partner to other educational networks, at this meeting we are welcoming representatives from CEFI, somewhere here at least, who will discuss with us how to collaborate, what can we learn from each other. And we can see CDIO's people as the number of graduates who have gone through CDIO education. And if we make the estimate that there is 100 programs applying CDIO today, with each with 100 students, there is 10,000 students per year graduating from CDIO programs across the world. And in many different countries and on almost all of the continents, I should say. So there are schools in Europe, in Africa, North America, Southern America, Asia, and Australia. Not in Antarctica, but Christina Edström is going there for a workshop soon. So we'll see if that can happen too. So this gives an idea that this is a thing that is spread globally. And finally, you could, I think, see CDIO as a collaboration platform, right? And what are the components of that? Well, there certainly is the brand name, CDIO. You can say that that is something that is sticks, and like other brand names, that's both a strength and something that is a limitation, because people interpret it, people have feelings about it, positive or perhaps negative, but nevertheless, it is a brand name which is spread. There's the website, there is the book, there is a conference series, there is our regional meetings arranged across the world that you can take part in. So that was a few characteristics of CDIO of today, or a few elements of what it is. So let's step back and ask ourselves, what are success factors for sustainable educational reform? And why has CDIO become a long-term initiative rather than a sort of a project? Well, there's a number of factors that need to be in place. For one thing, CDIO has responded to a need articulated by stakeholders, and by stakeholders, we refer to students and to industry. An education that is attractive and rewarding for students, but also who leave industry ready to engineer. So in Sweden, we have a new boss for Volvo Cars who said wanted engineers who knew how to make hybrid powertrains for vehicles right off the cuff today. Unfortunately, I don't think that we can deliver as many engineers as he wants, but it also shows a bit of the mindset of industry, that students that graduate should be ready to engineer from the start. And maybe that is something that is different from 15 or 20 years ago, when you could say, well, we'll hire someone as a trainee, they'll come in, and after a couple of years, they'll be able to do some real work. That is not what employers are hiring students for today, but rather to be productive very early on. And then they need a training to be engineers while they are at engineering school, not afterwards. There is this aspect of a vision, so knowing what it is that we want to, and be able to work towards that for a long time, be able to describe this, be able to communicate it in a few words. Summed up by setting engineering education in the context of CDIO and deepening learning of fundamentals while strengthening the professional skills as a vision. Program level scope, so looking at the educational program as a whole, seeing that it needs to deliver both knowledge but also skills, but it is a program that is composed by different courses that collaborate and so forth. And you need to form a group of teachers that work with the program, that collaborate with others. Something that is not a given when you go into engineering education or any university where people are individualists and perhaps want to say that I want to work on your course and you work on your course and the third guy works on his course. So the program level indicator, or program level strength, is something that makes CDIO programs work as a whole. Learning from others on scholarship and best practice, doing benchmarks. So I think that, for example, on Thursday we have the collaborators meeting where you hear from, we get an opportunity to hear from 9 different universities from across the world, what they see as problems, what they see on as approaches, is something that is quite unique, somewhere where you can get a lot of new ideas. Collaboration, co-development, networks, and regions, and so forth. Then there is the codification, syllabus and standards, where sort of what is this is put down in a bit more detail, making it operational in the sense that this is something that can use to the guide you when you write your program goals or when you modify the program goals as a template to start from, as well as something to say, well, what is CDIO? What is this? What is we aiming for? Having a continuous improvement process. Not demanding significant new resources. This is a common question when engineering reform comes up and say, well, what does it cost? Or maybe, this is a good idea, but this is going to be too expensive. And we have worked over the years to try to put forward approaches where we say that we retask the curriculum, we retask pedagogy, we retask space, we retask faculty skills without increasing the need for money in the long run. Support of the organizational process, organizational change process, workshops, consultations, materials. Continuous improvement framework with reviews. And finally, perhaps as a sex factor, the active promotion identity awareness. And we come back a bit to the aspect of a brand, something that is commonly known to many people involved in engineering education. Know a bit of this is what is the reference and so forth. But then again, you could also turn this around and say what would be barriers to wider adoption of CDIO or wider adoption of some other educational idea. So you need to take in place the aspect of not invented here. So it could be a general fear of or resistance towards new ideas, but because it's proposed by someone else, and especially I don't like that person, but so forth. So we're not going to like that. There's also that never happened. Of course it didn't. So, but that's also the aspect perhaps of local competition. We have our own branding. We can call this design thinking, or we can call it something else, and then we don't want to listen to other ideas because they are competing with what we have already. There is the lack of faculty competence in design, and in some cases you might say that, well, faculty has no competence in design because we are dealing with analysis or something else, but even in the places where there is faculty competence in design, it would tend to be very limited, right? Hanging on a few individuals who maybe had some professional practice and know how to design. But of course, you become very vulnerable if someone leaves or get a better offer or something like that. A lack of understanding of the need for authentic context. Sometimes when I speak to faculty from other departments, they say, well, maybe that's good, but we should focus on what we know and let industry focus on what they know. And then in that case, you almost define things that you want to teach as something different from what they're doing in industry, because they can pick that up while they're there anyway. So we should teach them something else. And since they are not teaching them enough mathematics in industry, maybe we should do a bit more of that. Or something else, if I'm a bit buoyant. But they, with that attitude, they sort of don't understand where the students are coming from, where we earlier could have students that did have some concrete experience of engineering prior to going to engineering school, and now we have not. So that is not something that you can take for granted. And it does not take into consideration the Jacobi version of that. Someone comes to us and needs to be able to ready to engineer from day one. And how can you be that unless we have trained them in that content, discussed that over the time? Research-oriented programs of faculty may say that, well, CDIO is just design, and thus it lacks appreciation of analysis. Okay, so I think we are trying to say that many times over, but maybe still. We also tend to get this reaction. Well, CDIO is a structured educational concept that implies a stronger program level, a top-down perspective, and a lack of flexibility. Okay? And we also get that when we ask someone, what is a catalyst for introducing CDIO? Yes, it is a catalyst for adoption, that it has a stronger program level, a top-down perspective, and some kind of principles for organizing the curriculum. So this is something that goes both ways, and it's very difficult to discuss, perhaps, that what is the proper way. There are interpretation and translation issues. We discussed earlier the aspect of CDIO coming from the mechanical and aeronautical. How does that translate into civil engineering or chemical engineering or biotechnical engineering? What does design mean in these concepts? What does implementation mean in those contexts? There's a translation issue there. Another translation issue is between, say, design and related concepts such as innovation. Okay, you're doing design, but we're doing innovation, and that is something that is different. How? Well, that's difficult to explain. Fear of costs, or the fact that faculty are too busy and don't want to take on a major change. So what can we see in the future then? Well, needs evolve, and CDIO must keep up and even lead. And if we see what we have doing and what has evolved during the last few years within CDIO, there's a number of new themes that have emerged which are rather different, I should say, from the first ones. And these include internationalization and mobility, sustainability, leadership, and entrepreneurship. New things that are on the agenda, broadening the scope of CDIO, you might say, from design to something that views and design in a national context to more international, to sort of asking a different question of engineers, from providing the best product to providing a sustainable future for mankind, for addressing some new things, leadership, entrepreneurship, which are also strong needs. CDIO should continue to work with national and international regulations, reflecting ABATS and its correspondence. And we can foresee a broader use of the framework, for example, in the context of UNESCO and China, where CDIO can be applied in a more comprehensive way. And then, as a final remark, we see here at this conference a massive effort to engage students in the conference in forms of the CDIO Academy, and in the framework of CDIO as a whole. I hope we can see much more involvement of students in the future. Can be versions of the CDIO Academy. There could be joint project courses between universities or student exchanges. But that is a general direction. Thank you.
It looks like Johan is ready to answer maybe one or two questions. And I'm sure Ed could also be drawn into that. One or two brief questions.
I think that in looking at the success factors of CDIO, you missed one crucial success factor. And in this retrospective of 10 years, I think the number one reason that CDIO has been so successful is because of the dedication and commitment of its own leadership. So I'm not asking a question. I want the audience to join me in a vote of thanks to the CDIO leadership for the wonderful job that you've done in creating the program, in building it up, and preparing it for the future.
Very nicely put question, I think.
Well, I think that this question cannot be followed. And if you'll please come up here, Ed, too. We just have a few tokens of appreciation. We have here, actually it's 2 books, but one will be sent to you by mail because it's pretty heavy. So I'll give this to you. It's a book. It's not CDIO images, it's CDTU images. So it's a book you will have yours sent, but here's a small token of appreciation. It's a DTU lamp, or torch, as I would say it, being sort of English, but it's a torch. That's something with fire in North America. So it can shed a little darkness, should there be any left for you two guys. Thank you very much.